Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called A Square Caged Ring by Megan33, and here are the rules. Normal Sudoku rules apply, which means fill the entire grid with the digits 1 through 9 without repeats in any row, column, or box. Digits in a cage do not repeat and sum to the clue in the top left. So for example, these 8 digits have to add up to 44. These 3 digits add up to 16. These 3 digits add up to 9. These 3 add up to 17, etc., etc. So as an example, we could have something like 2, 9, and 6 here. And that would be valid because these 3 digits, 2, 9, and 6, add up to 17. And then we also have crop key dots, where a black dot between cells indicates cell values with a 2-to-1 ratio. A white dot between cells indicates cells with consecutive values, and not all dots are given. So, for example, if this were a 4, this would have to be 2 or 8 to maintain the 1-to-2 ratio here. If this were the 6 that we had earlier, then this would have to be 5 or 7 to make sure that these 2 digits are consecutive. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so for me, this is a dead giveaway that this is going to be a Fistamafel ring. Fistamafel ring theory puzzle. Because this is what is known in the variant Sudoku community as a Fistamafel ring. Because there was this, I don't know if he was a solver, but basically he set a lot of puzzles. And he sort of came up with this theorem, that basically these cells surrounding the middle center box in a Sudoku puzzle must be exactly the same as the digits that are in the 4 corners, the 4 2x2 corners of the Sudoku puzzle. And I mean, it was actually quite, I thought it was very brilliant because it's the way that he solved, or the way that he showed the proof was basically this way. What it is take the middle 5 rows and mark it as a set, right? Then, let me see. Let me think if I can remember how to. It's been a while since I've actually just explained this. Then remove the the center of that area. What are the digits in this orange space? They have to be 4 sets of the digits 1 through 9, right? Because you know, first of all, if we do it without the center box, we know all the rows contains each one. Again, you must have the digits 1 through 9 without repeats in any row. So therefore, it must be the digits 1 through 9 5 times, right? Because you have 5 rows, you don't have repeats, so it's the digits 1 through 9 without repeats. So if you take out, so this original orange space is 5 sets of the digits 1 through 9. If you take out the center box, you know every box doesn't have a repeat either. So that also must be a set of the digits 1 through 9. So if you have 5 sets of the digits from 1 through 9 and you remove the center box, that removes one of the sets of digits of 1 through 9. So therefore that leaves you 4 digits of the set 1 through 9. Well, interestingly enough, take the outer columns in the Sudoku puzzle. What are the sets there? They must also, since there are no repeats in any column, they must also have 4 sets of the digits 1 through 9. So basically, the orange region that I've shown and the green region that I've shown have exactly the same digits, right? They both must contain the 4 sets of the digits 1 through 9. And interestingly enough, you have an intersection between these sets, right? These 10 digits here and these 10 digits here. Well, if you remove those 10 digits, they're in both of the orange set and both the green set. If you remove those digits entirely, that would mean these sets are still exactly the same, right? Because before you remove those, they both contained 4 sets of the digits 1 through 9. But since they're in both, they're exactly the same digits. So if you remove them from the orange set, you're removing exactly the same digits that you're removing from the green set if you just remove the digits that overlap or the cells that overlap. That's how you've proven that the orange ring, which we now call the Fistomathel ring, is equal to the 2x2 areas in the corner of a Sudoku puzzle. And so that is, and anything that you have a ring-like shape around essentially the center box, you can always use this theorem to simplify things a lot. And it does simplify things a lot because a lot of a lot of puzzles would be a lot more difficult if you didn't have this theorem. And a lot of puzzles are actually built on this, so that's why maybe it becomes easier. But the interesting thing is, this is an 8-cell cage that adds up to 44. What does that mean? That means these are the digits 2 through 9, because you can't have repeats, and they must add up to 44. Well, and you have 8 digits, right? What's that last digit have to be? It has to be 1. So there's no 1. These are the digits 8, 2 through 9, and these are the digits 2 through 9. Well, what does that imply in these corners? There is no 1 in the corner. Therefore, if you know there's no 1 in the corner, this 3-cell cage adding up to 9 cannot contain a 1. And therefore, it must exactly be 2, 3, and 4. So this is 2, 3, and 4. 2 can only be in a ratio with 1 or 4 with 1 to 2 ratio. So this cannot be 2 because, again, 1 cannot be in the corner 2x2 boxes, or 2x2 squares, I should say. So this can't be 2. It could be 3 and this is 6, or 4 and this is 8. Similarly, this 10 cage cannot be 127, can't be 136 or 145. It can only be 2, 3, and 5 here. Well, the 2 could be with 4 this time because it couldn't be with a 4 here because we already had a 2, 3, 4 triplet in that cage, which eliminates 2, 3, 4 in the rest of the box. But this 2 could have a 4 here, and this 3 could be with a 6. And again, you cannot have a 1 in this 2x2 square, right? Because you know you don't have a 1 in the Fistomathel ring. So this cannot be 5 because 5 is not in a 1 to 2 ratio with any digit. So this is either 4 or 6. Well, for these 2x2 areas, we know we have a 2, 3, 4 in this cage and a 2, 3, 5 in this cage, which means we have 2 2s and 2 3s already accounted for in the 2x2 all the 2x2 squares. Well, there's only 2 2s and 2 3s in Fistomathel's ring, So therefore, the rest of the 2 by 2 areas cannot contain a 2 or 3, right? Because there's only two 2s and two 3s, and we've already counted for all of them in these cages. So therefore, in this cage, then, we know there's there's only two 2s. There's only 2 of each digit except for 0 1s, right? There's two 2s, two 3s, two 4s, two 5s, etc., all the way up to two 9s, right? So this cage cannot contain a 2 or a 3, since it can't, or a 1. So since this can't contain a 2, a 3, or a 1, what can it contain? Well, the only one you can have starts with a 4 at minimum, right? Because you can't have 1, 2, or 3. So if you take 4 and you have 5 and 6, the minimum amount for those 3 digits is 15. And if you just add 1 to the 5, that leaves the only possibility that you can have for a 16 cage without 1s, 2s, and 3s. So you know you have 4, 5, and 7 here. Well, here you have a 2, 3, 4 triplet. Here you have a 2, 3, 5 triplet. And here you have 4, 5, and 7. That means 2, 3, 4, and 5, we already have 2 representatives of each. So actually, that does prove something. This can no longer be a 4, right? We have a 4 here. We have a 4 here guaranteed. But we only have 2 4s in the 2 by 2 squares all together, right? Because, again, the Fistmafels ring, you only have the digits 2 through 9 twice. So this cannot be a 4. It has to be a 6, which makes this a 3. These can't be 3. This is a 2-5 pair, which means this cannot be 5. This is a 4-7 pair, which eliminates 4 and 7 in the rest of the box. So this must be a 5. Yeah, this 2-5 pair eliminated 2-5 in the rest of the column, which is why we could eliminate 5 here. Now, we have this 2 by 2 area cannot contain a 2, a 3, a 4, or a 5. Well, if that's the case, what can it contain in this 21 cage? It can only be 6, 7, and 8 to add up to 21, right? Because you can't have 2 through 5 anymore, right? Those are eliminated because we have 2 of each of those, right? We have we have a 2 here, we have a 2 here. We have a 3 here and a 3 here. We have a 4 here and a 4 here. We have a 5 here and a 5 here. So this must be then 6, 7, and 8. Well, what are the digits that we're missing now from the Fistmafel rings? If you notice very closely, we're missing 2 9s. So that means, where are the 9s? They have to be in the spaces which cannot be, which are not designated as 9. We also have a 6 here and a 6 here, which means this cannot be 6 anymore because we have 2 6s now in the 2 by 2 squares on the corners, and there's only 2 6s in Fistmafel's ring, which are exactly the same digits. So this must be an 8, which makes this a 4. These can't be 4 anymore. This 4 means this can't be 4, so that's a 7. Oops. This is a 7, and that's a 4. This can't be 8. So we have that scenario. And if you notice, what digits do we have in the corners now? We have a 2 here, so 2 2s, a 3 here, a 3 here, 2 3s, 2 4s here, a 5 here and a 5 here, 2 5s, a 6 and a 6 here, 2 6s, a 7 and a 7 here, 2 7s, and an 8 here and an 8 here, which are 2 8s. And then we have the 2 9s. So that's one way, that's basically how Fistmafel's ring makes things much easier. Because since we know, we've shown this theorem and how it works, we can basically feel confident that these are the digits that we must have. Now, what about these digits? This is a 1 to 2 ratio. The only digits you can have in a 1 to 2 ratio are 1 to 2, 2, 4, 4, 8, and 3, 6. But 1, 2, 2, 4, and 4, 8 are eliminated because we have a 2 and a 4 already accounted for in the column. So this must be specifically 3 and 6. Similarly, here we have a 16 cage. Actually, let's go here. We have a 17 cage, which cannot contain 4, 5, or 7. Well, what can it have then? You can't have a 1 because 1 requires the 2 digits 7 and 9 to be with it to add up to 17, and that's the only set that requires a 1. You could have 269. So actually, the 269 that I was talking about earlier could very well be the solution here. 278 doesn't work because we don't have a 7. So that's all the 2's available. If we have 3, you cannot have 359, but you could have 368 adding up to 17. So this is either 269 or 368 so far. It cannot have 4, and it cannot have 5 as the lowest digit. So these are the only options. So we know a 6 is in one of those 3 cells, which means in the other cells, one of these must be 2 or 3. This must be 2 or 3. That eliminates 2 and 3 from the rest of the row. So therefore, the remaining digits must be 1, 8, or 9 in the row. And this can't be 8, and this can't be 9. So one is in one of those areas. We're not sure which. What else do we do? Let's look at this. Actually, let's look at this cage here. This is in a 1 to 2 ratio here. And again, you can't have 3 because of a 3 in the row. It could be 1, 2, 2, 4, or 4, 8. But if it's 1, 2 here, the problem is 1 has to be consecutive with a 2. So that would be eliminate that possibility in this row. If this is 2 and that's 1, this would have to be a 3. And that eliminates that possibility in that row. So 2 and 1 is not possible here. It could be 2, 4. So that's fine. So if this is 2, this is 4, this would have to be a 1 because 3 is not available. If this is 4 and this is 2, this cannot be 1, but it could be 5. But that doesn't work because we already have a 2, 4 here, which makes that a 5. But that would eliminate all possibilities for that cell. So we cannot do that way. So if it's 2, 4, it has to be this way too, and that's a 4 with that 1. It could be 4 and 8 though. If this is 4 and that's 8, this could be a 5. It cannot be 3. Or if we have an 8 here and a 4 here, well, if we had 8 here and a 4 here, that would eliminate 8 in the rest of the row. So this would then be a 6, 7 pair. So this could not be 6 or 7 in the rest of the row then if this is a 4, 8 pair. So if this is 4, this is 8, this cannot be 7, but it could be 9. So these are all possibilities. We know the 4 is here. And that's all we know about that. We don't have very much more information about that. What digits are consecutive here? Actually, let's look at this cage too. Let's continue. This is the last one of the rows and columns that we have a lot of information about. So it cannot have a 2 or 3 because of the 2, 3 pair in column 1. So it must have either 1, 4 as the lowest digits. Again, like if it's 4 as the lowest digit, it can only go at 4, 5, and 7. You cannot have 5 as the lowest digit here, because if you tried, it would be 5, 6, and 7, which adds up to 18. So this is only 1 as the lowest digit or 4 as the lowest digit. You could very well have 1 as the lowest digit. It could be 169. It cannot be 178, because if it's 178, that would eliminate all possibilities for that cell. You could have 4, 5, 7, though. So this actually could be a wide variety. Okay. But the thing is, this is 6 or 7, basically. That tells us, right? Because it cannot be any other three-digit combinations. So it's either 169 or 457. So it must contain a 6 or a 7 in these three cells. Well, one of these two cells must be a 6 or a 7. So therefore, the rest of the column cannot contain 6 or 7. So we can just fill those in. It could be 1, not 2 or 3. It could be 4 or 5. No 6 or 7. No 8. So then it's 9. So it's 1, 4, 5, or 9. This can't be 9 because of this 9. This can't be 4 because of that 4. So if this is 169, that would make this a 5. And therefore this would be 4. If this is 4, 5, 7, this would have to be 1, and this would be 9. So this could never be 1 here. These are consecutive. Also, we know these digits. Maybe that's a better way of doing things. Okay, yeah, let's look at column 9. What are the possible digits in column 9? It has to be 1, 8, and 9. This is 1, 8, and 9, and this is 1, 8, and 9. Well, this can't be 1, because if this were a 1, it would be consecutive with 2, but the 2 is already taken by the 2, 5 pair. If it's 8, it could be with 7. This could be with 8 or 9, but 8 then has to be one of these two digits, right? This cannot be 9 because of the 9 in the box. What are the remaining digits in that box? It's 2, 3, and 6. 4, 2, 3, and 6. Because of the 1, 8, 1, 8 pair in the box. The rest of these digits are 1 through 5. This can't be 3, and this can't be 4. We don't have any other information. Okay, so if this is 1, 2, and 4, we do actually have that information. If this is 1, 2, and 4, that eliminates 1 and 2 here, and 2 here, which makes both of these 5, which is not allowed by normal Sudoku rules. So this cannot be 1, 2, and 4. It's specifically then 4 and 8. So we have a 4, 8 pair here with 5 or 9 here. Well, the 4, 8, 4, 8 pair eliminates 4 and 8 from the rest of the column or the row. This can't be 8. We now have a 6, 7, 6, 7 pair in row 9 and in this box. So the rest of the box cannot contain 6 or 7. Therefore, this is an 8. This has to be 1, 2, 5, or 9. And it cannot be 2 or 5 because this is... We have a 2, 5 pair in the box. So this is 1 or 9 here. These have to be consecutive. If it's 1, it has to be 2 here. If it's 4 or 5, it could be with 3, 4, or 5, but 4 can't be here because of the 4 in the column. This can't be a 1 because, again, this 44 cage cannot contain a 1. The rest of these digits are, we cannot have an 8, but it could be 1, 4, 7, or 9 here, but it can't be 1 here. So one of these two must be a 1, because this can't be 1 anymore here. So since one of these is a 1, this can't be 1, so this must be 8, which makes that a 1. This 8 means this cannot contain an 8, so it cannot be 3, 6, and 8. It must be specifically 2, 6, and 9, which means this can't be 9. This is a 1, which makes this a 3 and this a 2. That's 3 in the corner. We celebrate because we know actually we're getting close to solving this. This can't be a 1 here. Where can the 1 be in this box? It can only be here. So this is 1, which makes this a 2. None of these can be 2s. This can't be a 2, so this must be a 5, which makes that a 2, which makes that a 5. This 5 also makes this a 9, which makes that an 8, because 8 is only 9 is only consecutive with 8. Therefore, that's a 4. These can't be 2 and 5. This cannot be 1, 6, 9, so it must again be 4, 5, and 7. This 4, 5, 7 triplet eliminates 4, 5, and 7 from the rest of the column. This can't be 5, so it's a 9. This can't be 7, so it's a 6, which makes that a 7. This 9 means this can't be 9, so this is a 1, which makes that not a 1. These digits are consecutive. 2 can be consecutive with 1 or 3. 6 can be consecutive with 5 or 7, and 9 can be consecutive with 8, but that's not possible there, so this can't be 9. What are the remaining digits in column 2? We have 1, 3, 5, and 6. Well, 5 cannot be any of these because of the 4, 5, 7 triplet in the box. So 5 must be here, which makes this 1, 3, and 6. And the remaining digits now are 2, 8, and 9 in that box. These digits must be 6 and 7. So that's fine. This is 2, 6, and 9 there. 8 has to be one of these two digits. That's fine. This is a 3, 6 pair. This can't be 1 because of this 1. This can't be 9 because of this 9. And this can't be 3 or 6 because of the 3 or 6 in the column. So that makes this a 2, which means this can't be 2 here. So we have a 3, 6, 3, 6 pair. We already kind of knew that, though. This is a 1 to 2 ratio. Do we have any information there? Not particularly. 5 cannot be here. 5 has to be here and then here. Okay, where is the 5 in this 44 cage? Can't be here, can't be here. It must be here. So this is a 5. And the 5 in this cage is here. That's fine. Let's see. In this cage, then, there has to be a 4. So it has to be one of these is a 4. What else are we missing? 3. No, 3's here. Could be here. So 3's 1. Okay. 6 and 9 and 2 cannot be here in this cage. Where can it be in this cage then? It can only be those two cells. So this is 2 and 9, which forces this to be 8. This has to be some combination of 4, 3, 6, 7, and 8. We're not sure which. 8 cannot be in the rest of this cage. That's fine. 5 cannot be here. That's fine. Where can 2 be? 2 has to be one of these digits. Because it can't be here. So 2, 9 pair. This is 8, which means this can't be 8, which forces that to be 9, which makes that 8, which makes that 7. So these can't be 7 anymore. We know what these two digits have to be then. It has to be 2 and 7 here. And the remaining digits here are 3, again, you have 3, 4, 5, 6, 9. But the 4 and 9 cannot be here, which makes this a 3, 5, 6 triplet. Also, the 6 cannot be here because of its 2, 6, 9 triplet here. So this is a 3, 5, 6 triplet now, which eliminates 3, 5, and 6 from the rest of the row. Therefore, this is 4. This can't be 4 anymore, so it's a 9, which makes that a 4, which makes that a 3. Okay, these 3 digits must be 1, 2, and 7. Those are the only digits remaining for the box. This can't be 4 because of the 4 in the column. The 3 and the 4 has to be here. The 4 and the 8 have to be here. That's all we know. This can't be 8 because of the 8 in the column. What can this 11 cage be? Also, this can't be 5 because of this 5. What can this 11 cage be? It cannot be 2, 9 because that eliminates all possibilities for that cell. Cannot be 4, 7 because that eliminates all possibilities for that cell. And it cannot be 5, 6 because of the 5 in the row. So it has to be 3 and 8. That's the only two pairs that add up to 11 that's remaining. This can't be 3, so this must be 6, which makes this a 3. This 3 here and this 6 here eliminates 3 and 6 here, so this is 1. This can't be 1 or 3 because of this 3 and that 1, so this is 6, which makes that a 3. These two digits are in a 1 to 2 ratio. Cannot be 3, 6, so it's either 1, 2, 2, 4, or 4, 8. Cannot be 4 and 8, though. So therefore, it's 1, 2, or 2, 4. So 2 has to be one of these two digits no matter what. So it's either 2, 1, or 2, 4. Either way, this can't be 2, so that makes that a 7, which makes that a 2. This 7 means this can't be 7. This 2 means this can't be 2, so this is a 9, which makes that a 2. Where is the 9 in row 4? Cannot be here because of this 9. Can't be here because of this 9, so this must be a 9. So that's a 9. This 1 or 2 is consecutive with this digit. Well, the problem is... Actually, is there a problem? It could be 1, 2, or 3, but it can't be 2 or 3 here, so this must be specifically 1, which makes that 2, which makes that a 4. Which makes that 5. This can't be 5. This 2 means this can't be a 2, so that makes that a 6. 6 is only consecutive with 5 or 7 here. These can't be 6s. This can't be 1 or 2, so that makes that a 7 because of this 1 or 2. This can't be 6. This can't be 7, so this must be 5, which means this can't be 5, so this must be a 3, which means these can't be 3s, these can't be 7s. This can't be 3 or 7, so that makes that an 8, which means this can't be 8. This can't be 4. Where is the 4 in row 3? It has to be here. And now the rest we can probably do by Sudoku. In row 4, what digit is remaining in that cell? It can only be 4 and 7 because the 3-8 pair eliminates 3 and 8. So this can't be 7 because of that 7. So this is 4, which makes that 7, which makes that a 4. In row 7, what are the remaining digits? We have 1 and 6. This can't be 6, though, so that makes that a 1, which makes that a 6. This 6 means this can't be 6, so that's 5, which makes that a 6. The remaining digits in row 5, oh, this can't be 8 because of this 8, so this must be 3, which makes that an 8. This 9 means this can't be 9, so this is 2. That makes that 9. This 2 means this can't be 2, so that's a 1, and that's a 2. We have, what is remaining here? In row 5, well, this has to be an 8, and this has to be 5 or 7. This can't be 5 because of that 5, so that's a 7, that's a 5. The last remaining digit in column 4 is a 3, so that's 3, which means that can't be 3 here. So that's a 6, which makes that a 3. Therefore, that's a 7, 6, 7, and the last digit remaining is a 1. And that's how you solve it. So yeah, I wanted to do this puzzle specifically, actually, because I wanted to highlight Fistomefel's ring, because it's a very useful theorem that basically allows you to shortcut, I guess, a way of solving these variant Sudoku puzzles. Anyways, I hope you enjoyed this episode of Learn How to Sudoku and learning about Fistomefel's ring if you haven't learned about it. And I'll see you next time on Frank Puzzles. Take care.